Welcome to the Calculus B section. In this section we'll be discussing area of surface revolution. So what is a surface of revolution? So the area of a surface revolution is the area under a function if it were revolved around an axis or another line. So in the previous section we learned how to get the arc length. So let's say we had the graph as follows. And we figured out that the arc length looks something like this. So if we were to rotate this arc length 360 degrees or 2 pi around the y-axis per se, we'd get something that looks like a vase. So this would be on this side. I would draw it this way, but our screens aren't three-dimensional, so I can try to use these circles to almost depict it. So that would be our surface of revolution. That's the surface. It would look like a vase, obviously, with a hollow interior because it's just the surface area. So essentially, all we're doing with our previous equation, L equals the square root of 1 plus dy dx squared dx, or L equals the square root of 1 plus dx dy squared dy, all we're doing is adding a 2 pi y or a 2 pi x to it. So the surface area, when dealing with the x-axis, would be the integral from 2 pi y, the square root of 1 plus dy dx squared dx. And when dealing with the y-axis, it would be the integral of 2 pi x square root 1 plus dy, oh, my apologies, dx dy squared dy. Now, say we were to have a problem like, we're going to draw a line to make it, oh, well, that's not what we want. We're going to make a separation here, and we are going to do a problem. Now let's say we had the function y equals 2x plus 1 over the interval 0 to 2 with regards to the x-axis. That's the revolution. So we are going to use the equation s is equal to the integral 2 pi y square root 1 plus dy dx squared dx. Now, first we're going to find our dy dx. Well, when we take the derivative of 2x plus 1, we know that it's going to equal 2. And additionally, after plugging this into our equation, we know that our y is our original equation of x squared plus 2x plus 1. Now, we know this is 2x plus 1 because y naught, or y0, is equal to 1. So that means when we take the integral of our y, 2x plus 1, we're going to say it's x squared plus x plus c, and because our y naught is 0, it's going to equal 1, so x squared plus x plus 1. So that means when we take our integral, we can put the 2 pi on the outside. We can say 2 pi integrand x squared plus x plus 1, and then square 1 plus 2 squared dx. And now this is going to give us 2 pi integral x squared plus x plus 1, and that's going to be 4 square root 5 dx. And this comes out to, from 2 to 0, this comes out to equal 2 pi rad 5 26 over 3. And that is the area of surface revolution. Now, if you need more help or need additional resources, the website has a bunch. I hope that helps. Thank you.